Well, we had a twofold research question, to be honest. One was very fundamental. How do we make sure that we can get to selective separation to recover nutrients from a nutrient-rich waste stream? So which technology can we develop, for example, to recover nitrogen, phosphorus, and potassium? That was a very fundamental research question. On the other side, both myself and Sebastian, we had a very keen interest in the sanitation problem in developing countries. What currently happens there is that people go to the toilet, so their urine contains a lot of nitrogen, and that nitrogen, when it enters the soil, so people go to the toilet in a latrine, when that nitrogen enters the soil, it's transferred into nitrate, and that nitrate contaminates their drinking water because they pump up drinking water next to the latrine where they go to pee. So that nitrate actually causes a lot of problems, a lot of health issues, things like blue baby syndrome, for example. So we wanted to know how can we tackle that problem and at the same time give something back. And there the circular economy starts playing a role. Instead of removing the nutrients that now go into the latrine and contaminate the drinking water, we wanted to recover them so that the farmers in those regions had extra access to fertilizers to fertilize their crop, which they currently don't have access to because they're too expensive. We see three main advantages. The first one is that it's sustainable. It recovers resources, in our case nutrients, rather than destroying them and actually remaking them or regaining them from mining deposits, for example. And it uses sustainable energy. We work entirely based on solar energy, and that's a key advantage. That key advantage also helps it to work completely standalone. It can work on any decentral location, so it can be placed in remote locations. And it's also perfectly scalable, so it can work for very large villages, for example, but also for small villages. And the third advantage that we see is the fact that it is very robust and it is able to cope with peak loads. And that's because we use a non-biological system. So it doesn't require live bacteria, for example, to do the trick. Which means that it can be switched on and off momentarily, and that's very important when you deal with peak loads. For example, if you have a large flow at a certain moment and no flow at another moment, we don't require any buffering capacity. So as a result, our installation also becomes cheaper. In fact, the first pitches that we did, we were still very much scientists. So what we said, because we are focusing on selective separation, we said we really want to target the removal of nitrogen via our custom-made membrane system, and we want to target the removal of phosphorus and potassium via a crystallization product. And we really focused on how should you do that and why is it in fact scientifically new. Now we do it completely different. Now we actually target our key message towards the client or the person that we want to bring that message to, the target audience. So in fact, when we now talk to, for example, a potential client or a potential investor, we really relate to what the current problem is. For example, if we talk to farmers, which are a potential client, we say, well, you currently have the disadvantage that you want to bring a lot of manure onto the land, which contains a lot of nutrients, but you're faced with regulation. You're not able to do that. And because of that, you have to go to an external manure treatment installation to recover or to basically treat that manure. What we do is we recover those nutrients and we actually give you new access to the nutrients so you can bring them back onto the land without having to pay for that external manure treatment. So we really target our key message to the problem that the person that we want to explain it to actually has. In fact, when we started to see that the installation was working well in the lab, we wanted to do some larger scale trials, some continuous experiments, because if you do continuous experiments, you always see different things than when you do these small scale batch experiments in the lab. So we started to look for a stream with full of nutrients that was continuously available. And of course, we're in Ghent, so the Ghent Festival was the best location to do that. So there we had access to a lot of urine from, basically the festival goers. Once we started doing that at the Ghent Festival, we actually saw that there was a lot of attention. There was a lot of attention. People were interested. We actually got calls from people who wanted to buy it. We got newspapers calling from worldwide. So we saw that there really was a potential for the technology. And that combined with a very keen interest in solving the sanitation issue in developing countries, that led us to thinking, how can we now turn this into a business that actually solves this problem? What do we need not only to convince the client, but actually to turn this into an organization that is sustainable, that not only makes a profit, but that is able to sustainably deliver this product into the market and actually solve the issues that we originally wanted to solve.